Welcome back, students. We will continue and try to wrap up the chapter. This is the portion of acids, base and salts, whatever is left. So this is the third video and we will continue with our chapter, which is acids, bases and salts. We had learned about acids, bases, indicators, acid rain and the different properties which separates an acid from a base in the previous two videos. We had seen a lot of color changing reactions, but in this video we will learn about a specific kind of reaction called the neutralization reaction. Now, why are we studying neutralization reaction? We know that acids are corrosive in nature, bases are bitter in taste, but we don't know that what happens when an acid reacts with a base. Let us have a look at what happens when an acid reacts with a base. What is neutralization? Well, neutralization is where an acid reacts with a base. It is a process or a chemical reaction in which an acid and basic substance is mixed with each other in order to neutralize their acidic and alkaline nature. So, why are we mixing an acid with a base? In order to neutralize them. And hence, since we are neutralizing their effect, we call it a neutralization reaction. The product that is formed after the neutralization process is called a salt. So, whatever salts we are seeing is actually a result of neutralization process. Whatever salt exists in nature is actually formed due to the reaction between an acid and a base. Salts can have basic, acidic or neutral nature. Let us have a look at this picture. Acids and base give rise to water and salt. For example, an acid such as HCl can react with a base such as NaOH, hydrochloric acid and sodium hydroxide, forming H2O and sodium chloride, which we consume as our normal daily salt. The neutralization process results in the generation of heat, which raises the temperature of the reacting mixture. When the neutralization reaction is taking place, some amount of heat is generated and it results in the raising of temperature of that particular mixture. A synthetic indicator often used for testing neutralization reactions is phenolphthalein solution. It is pink in color. It's an indicator that can be used for testing neutralization reactions as well. When an acid is added to phenolphthalein solution, the solution turns colorless, indicating the presence of an acid. So, we know that when phenolphthalein is added to acid or acid is added to phenolphthalein, the solution turns colorless. But when a base is added to phenolphthalein, the solution retains its pink color, indicating the presence of a base. So, we have learned this in the previous video that phenolphthalein is colorless in acidic solution and pink in basic solution. The following activity demonstrates neutralization reaction with the use of phenolphthalein solution. Let us have a look at the activity. The materials required are test tubes, dropper, phenolphthalein indicator, dilute hydrochloric acid solution and dilute sodium hydroxide solution. What is the procedure? About 5 ml of dilute solution of sodium hydroxide in a test tube is taken. So, 5 ml of sodium hydroxide is taken in a test tube. Add 2 drops of phenolphthalein indicator to it. The solution in the test tube turns pink. So, when dilute solution of HCl is dropwise added, after adding NaOH, we will see what happens. First, let's see what is happening here. 5 ml of dilute sodium hydroxide is taken in a test tube, which is basic in nature, and 2 drops of phenolphthalein indicator is added. What happens when base is added to a phenolphthalein? When phenolphthalein is added to base, it turns pink. We have learned in the previous video. Now add dilute solution of hydrochloric acid dropwise using a dropper and shake the test tube to mix the solution. Stop adding hydrochloric acid when the pink color of the solution disappears. So, we have to keep on adding dropwise HCl solution until the pink color disappears. Now add a drop of sodium hydroxide solution and shake the test tube to mix the solution. What do you see? Keep repeating adding the sodium hydroxide and hydrochloric acid solution one after the other and watch the appearance and disappearance of pink color. So the moment you add phenolphthalein to a basic solution, it turns pink. When you add acid to that solution, it becomes acidic again, so the color disappears, it becomes colorless again. Again, if you add sodium hydroxide to the solution, it will again turn pink. So what is happening? As soon as you're changing the acidity or the basicity of the solution, the color is changing. Touch the test tube after reaction is over. Does it appear warm? Let's see what the observation is. The solution turns pink. The pink color disappears when a drop of HCl solution is added to the solution in a test tube. So the moment you're adding HCl, the pink color is disappearing, and the moment you're adding sodium hydroxide in some amount, the pink color is reappearing. And during this entire thing, the test tube is appearing to be warm on touching. Why is it happening? The addition of hydrochloric acid destroys the alkaline nature of sodium hydroxide. On the other hand, the addition of sodium hydroxide destroys the acidic nature of hydrochloric acid. That is, both sodium hydroxide and hydrochloric acid appear to cancel the effect of each other. Such a reaction between an acid and a base is called neutralization reaction. So what is happening? Look into it. As soon as you are adding an acid, the medium is turning acidic and it is appearing colorless, and the moment you are adding a base, the medium becomes basic and it is turning pink in color. This continuous process of acid and base mixing is called a neutralization reaction. And what is happening in a neutralization reaction? Heat is being produced. Here we come and learn about endothermic and exothermic reaction. Salt formed because of neutralization reaction may be acidic or basic in nature. Acidic or basic nature of salt depends on the strength of an acid and base. So the acid and basic nature of the salt depends on the strength. If the acid is stronger, the salt is acidic. If the base is stronger, the salt is basic in nature. In a neutralization reaction, heat is evolved. It is due to this heat that the test tube appears warm in the previous activity. Reactions in which heat is evolved are called exothermic reactions. Very, very important. Exo is coming from the word exit. Exit means going out, coming out. So reactions in which heat is evolved or produced are called exothermic reactions. On the other hand, reactions in which heat is absorbed are called endothermic reaction. Ending, getting somewhere. Ending somewhere means absorbed, taken in, ending. Thus, neutralization reaction in which heat is being produced is an exothermic reaction. It is producing heat. In the activity, when solution of sodium hydroxide is mixed with the solution of hydrochloric acid, both neutralize each other and common salt sodium chloride is formed. Since it is an exothermic reaction, so reaction becomes slightly hot. So look into this reaction. The reaction involved in this can be written as follows. This is there in your book as well. Sodium hydroxide or NaOH reacts with hydrochloric acid HCl. Na comes together with Cl and H2O is left behind. So water is removed, heat is being produced and sodium chloride is being formed. Another neutralization reaction between lime water and dilute sulfuric acid. Lime water was calcium hydroxide, CaOH whole 2, and sulfuric acid is H2SO4. So it forms calcium sulfate, which is again a salt, water and heat. This reaction mixture becomes warm also due to evolution of heat. So neutralization reactions are exothermic reactions, hence proved. Now we will have a look at some neutralization reactions in our everyday life. Remember the first slide we learned about indigestion? We know that our stomach produces hydrochloric acid, which helps in the digestion of food. So why is hydrochloric acid required? It helps in digestion of food. But sometimes the stomach releases too much acid, which leads to indigestion or sometimes hyperacidity. You might have mentioned the term, I'm feeling acidic or I'm having acidity at times. What is it? It is nothing but overproduction of hydrochloric acid in your stomach. Hence, we need to neutralize this acid by taking substances that are basic in nature, commonly known as antacids. For example, milk of magnesia is a basic substance that can neutralize the acid of the stomach. So, the different kind of antacids that you take, the pink colored medicines that you take, they are usually the milk of magnesia. They contain magnesium hydroxide. The moment you're taking magnesium hydroxide, the hydrochloric acid is reacting with the base. It is undergoing a neutralization reaction, forming a salt and water. So you do not feel acidic after taking the antacid. Next one is ant bite. The irritation of the skin due to an ant bite is caused because of the presence of formic acid that the ant injects into the skin while biting. Hence, we use a basic substance to neutralize the effect. For example, baking soda or hydrogen carbonate, calamine solution or zinc carbonate are generally used to treat ant bites. So, if you have ever suffered from an ant bite, you must have seen that the skin becomes there is an irritation on the skin, some sort of pain is there. That is because the ant injects formic acid into that portion while it bites you. And therefore, you can neutralize its effect. If you add some basic substance on that area of your skin, you start feeling better because that base reacts with the formic acid, forming salt and water. Next is soil treatment. Plants need a soil which is neutral in nature, but using chemical fertilizers on soil can turn it into acidic. To treat the acidic soil, we use quicklime, that is calcium oxide, or slaked lime, which is calcium hydroxide. So, these two things or certain other basic substances can also be used to neutralize acidic soil. Basic soil can be treated by adding organic substances to it so that they release acids while decomposing into the soil. So, if the soil is extremely acidic, you can neutralize it by using certain bases, and if the soil is extremely basic, you can neutralize it by adding acids to the soil. This helps the plants to survive the climate, survive the soil. Factory wastes. The factory waste is acidic in nature and cannot be directly dumped anywhere. Hence, bases are added to it before it falls off into a river or stream so that the aquatic life does not get affected. So, factory wastes, as we know, they contain a lot of pollutants, a lot of acids, and they cannot be dumped directly into the water because in the water many aquatic life, fishes as well as plants survive, and the acidic nature is not suitable for their survival. So, what happens? The factory waste is treated before it is dumped into the stream so that the aquatic life does not get affected. Now, let us have a quick summary of the entire chapter. What we have learned? We have learned that acids are chemical compounds found naturally in plants or derived from minerals. Example, citric acid, sulfuric acid, etc. The sour taste of many fruits and vegetables, lemon for instance, is due to various types of acids present in them. The word acid is derived from a Latin word which means sour. So, acids are always sour in taste. Some of the uses are manufacture of dyes, drugs, paints, fertilizer, as a food preservative, in soft drinks, in cooking, etc. Next, we learn about bases. Bases are oxides or hydroxides of metals. Calcium hydroxide, calcium is a metal. Magnesium hydroxide, magnesium is a metal. Sodium hydroxide, sodium is a metal. So, they are oxides or hydroxides. Soluble bases are called alkali. Sodium hydroxide, copper oxide are certain examples. They are bitter in taste and soapy to touch. Seawater and detergents are some examples of substances that are basic. And what are they used for? Manufacture of soap, batteries, preparation of mortar, etc. Next, learn about salts. They are the compounds formed when an acid reacts with a base, neutralization reaction. Example, sodium chloride, zinc chloride, etc. What are its uses? They can be used as food preservative, in freezing mixture, in cooking food, manufacturing fertilizers, etc. So, this is a brief summary of the entire chapter. We have also learned about indicators, very important, neutralization reaction. So, keep everything in mind. Now, if there are any questions that you all have pertaining to the entire chapter, you can post it in the comment section. I will revert back surely. Till then, keep learning your chapter. If there are any questions from acids, base and salts, post it in the comment section like I have already mentioned. Do not refrain from asking questions. Most welcome to ask questions. And if there are no doubts, you have understood the chapter, do let me know. That will help me understand that there were no problems in stating or making the facts clear. So, thank you everyone. Keep learning your chapters and at the same time follow the videos and follow your online classes at the same time. Thank you everyone. Have a very good day. Take very good care of yourselves.